From majestic cliffs and snow-capped summits to the undulating forms of ancient weathered ranges, mountains feature in the world's most dramatic landscapes. Through the ages, mountain heights have awed religious mystics and inspired poets. Mountains also challenge adventurers and attract tourists seeking a brief respite from their daily lives. Yet, mountain-building processes involve devastating volcanic eruptions and destructive earthquakes. These geophysical events are an inevitable part of living on a dynamic planet. Certainly, a world without mountains would be far less interesting than the planet on which we live. A mountain is any part of the Earth's surface that has a distinct summit rising above its surroundings. A mountain range is a series of mountains which lie in close geographical proximity and originated in the same way. Examples of mountain ranges within North America's Rocky Mountain system include the Lewis Range in Montana, the Grand Tetons of Wyoming, and the Uinta Range of Utah. Clustered mountain ranges found along an extensive elongated zone are often referred to as a mountain chain, or to use the Spanish term, a cordillera. For example, the dramatic Torres del Paine in southern Chile is part of South America's Andean Cordillera. Earlier generations thought that mountains endured forever. We now know that even the strongest rocks are gradually broken down as mountains are reduced in size through the processes of weathering, mass wasting, and erosion. Old mountains, such as the Appalachians in eastern North America, were uplifted many millions of years ago and have gradually been worn into rounded forms much lower than their original heights. Younger mountains, such as the Andes and the Himalaya, are high, rugged, and still growing. Volcanic activity and tectonic uplift continue to build the Andean peaks, and Mount Everest, the world's highest mountain at over 29,000 feet, increases in elevation about 1/2 inch per year due to the great pressures pushing it skyward. A major upheaval which creates mountain chains is called an orogeny, from the Greek word for mountain building. Periods of orogenesis are characterized by massive structural transformations of the Earth's crust. According to the theory of plate tectonics, these structural changes are generated from within the Earth as rigid plates of rock move over less rigid layers. These plates float on a thick, semi-molten layer of rock called the mantle. Intense heat from the core causes massive convection currents that set the surface plates in constant motion. The resulting tectonic processes include intense pressures which fold or fracture rock and produce igneous activity. Volcanism is a dramatic form of igneous activity that involves the movement of molten rock or magma from the interior of the Earth onto the surface. This extrusive igneous activity results in landforms that include volcanic mountains and lava flows. Volcanoes take several forms. Cinder cones are built up of materials that were expelled into the air during an explosive eruption and fell back down near the vent. Materials include pieces of solidified lava, rock fragments, and ash. They are called pyroclastics, meaning fire-broken rocks. A cinder cone is topped by a crater. This pit contains the opening of the vent through which gases and pyroclastic materials were ejected during the eruptions that built the cone. Cinder cones are often surrounded by lava flows that spread out from fissures near their bases. Most cinder cones are small and of geologically recent origin. Mexico's Paricutin volcano, for example, emerged from a cornfield in 1943. Within 2 years, it grew to a height of about 1,200 feet and buried nearby villages under ash and lava. In 1952, the eruption ceased, and the small mountain has been quiet ever since. The large conical shapes of composite volcanoes, such as Ecuador's Mount Chimborazo, are formed by alternating pyroclastic eruptions and lava flows. These mountains are called stratovolcanoes, in reference to their multi-layered composition. Symmetrical shapes characterize young stratovolcanoes, such as Mount Osorno in Chile and Mount Merapi on the Indonesian island of Java. Other stratovolcanoes, including Washington's beautiful Mount Rainier, have built 2 major cones during their eruptive histories. The summits of many active stratovolcanoes are pitted with deep craters. A large caldera, such as the one that contains Oregon's Crater Lake, may be created by a highly explosive eruption that destroys part of the upper cone. At Crater Lake, the original crater was enlarged about 7,000 years ago, when a massive ejection of pyroclastic materials was followed by the collapse of the mountaintop into the empty lava chamber. Later, a small cinder cone, now called Wizard Island, grew up from the caldera floor. Bali's active Mount Batur provides an example of a composite volcano growing in the caldera of an ancestral mountain. Calderas created by less violent eruptions also kept many of the gently rounded mountains called shield volcanoes. These volcanoes are formed when very fluid lava spreads out from vents to create large dome-shaped formations such as Fernandina Island in the Galapagos. Lava plugs, or plug domes, such as the Chaos Crags in California's Lassen National Park, are formed by the upward protrusion of very stiff lava. Mount Lassen, with a summit of 10,457 feet, is an exceptionally large plug dome, but most lava plugs are fairly small. A lava plug is currently growing in the caldera of Mount St. Helens, the Cascade volcano that lost most of its summit in a cataclysmic eruption on May 18, 1980. Active volcanoes erupt periodically, and a few, including Stromboli in Italy's Lipari Islands, remain in a nearly continuous state of eruption. A volcano which has remained quiet for a long time period, but is considered likely to erupt again in the future, is considered dormant. When volcanic activity ceases completely and is not expected to resume, a volcano is considered extinct. Over the eons, extinct volcanoes are modified by erosion so that they lose their distinctive conical shapes. Oregon's Mount Washington, for example, is crowned with jagged igneous rock which hardened in the vent of a cone that has since been stripped away by glacial action. One type of extrusive volcanism, the emission of highly fluid lava flows from fissures, results in the formation of a plateau rather than mountain building. Layered fissure flows, known as the Columbia basalts, cover extensive areas of eastern Washington and Oregon. The layers from different flows can be seen where they have been cut through by the Columbia River and its tributaries. Intrusive igneous activity involves the movement of magma within the Earth's crust. When molten rock solidifies without reaching the surface, igneous intrusions are formed. These bodies of rock, generally referred to as plutons, are revealed only after overlying earth materials are stripped away by erosion. Plutons are classified in terms of their shape, size, and relationship to the rock which was present at the time the magma began its underground movement. They include dikes, sills, volcanic necks, laccoliths, and batholiths. Dikes are formed when magma penetrates fissures that cut across the structure of the pre-existing rock. An example is seen here on Mount Moran in Wyoming's Grand Tetons. Sills, such as the dark band of diorite revealed on Montana's Mount Gould, form when magma is forced between parallel rock beds. Volcanic necks, such as this curious spike at Le Puy in France, are composed of magma that's solidified in a volcano's vent. A laccolith is a dome-shaped structure formed when a large mass of magma is forced through a small fissure into a layer of rock. The Henry Mountains of southeastern Utah have a laccolith core that has been exposed by the erosion of overlying rock layers. Batholiths are large, intrusive bodies of granite. These form the core of many great mountain ranges, including California's Sierra Nevada. Exposed rocks of batholithic granite in the high Sierras indicate that this fault block mountain range was partly created by the upward tilting of a massive batholith. As occurred with the building of the Sierra Nevada, intrusive and extrusive movements of magma may be accompanied by warping, folding, and faulting of solid rock material. Folding, which is easiest to see in layered sedimentary strata, occurs when rocks are bent but not broken under intense pressures. The degree of folding depends on a number of factors, including the strength of the rock, its temperature, the intensity of the pressures, and the duration of the compressive forces. Some mountain ranges result primarily from folding. The ridge and valley section of the Appalachians, seen here in a view from space, presents a classic landscape of parallel mountains and valleys developed on folded strata. Basic types of folds include anticlines, which are the crests of folds, and synclines, which are the troughs. Some mountain ranges, including the Alps and the Pyrenees, have highly complex fold structures. Landforms produced by folding are more varied than the folds themselves because the forces of weathering and erosion begin to carve the landscape as soon as uplift occurs. Faulting takes place when stresses break and displace rock. Earthquakes result when a sudden slippage occurs along a fault line, as took place in Alaska in 1964 and San Francisco in 1906 and 1989. Movements along faults may be vertical, horizontal, or both. Horizontal movements, in which the blocks of earth slip past each other with no vertical displacement, characterize strike-slip faults, such as California's San Andreas Fault. Vertical displacement along a normal fault, such as this one in Nevada, produces a steeply inclined fault plane with one block upthrown in relation to a downthrown block. The upthrown edge is called a fault scarp. Vertical movements can, over time, result in the uplift of major mountains, such as California's Sierra Nevada. Overthrust faults occur when compression forces an upthrown block to override a downthrown block at a relatively low angle. Chief Mountain in the Montana Rockies is an eroded remnant of a major thrust fault. Mountain building often involves extensive overthrusting. In the basin and range region of the western United States, fault block ranges are interspersed with a complex series of horsts and grabens. A horst is formed when a block of land is uplifted between two parallel faults, and a graben is created when a block of land is downdropped between two faults. California's Death Valley Graben extends 30 miles between the Black Mountains and the Panamint Range. Long graben structures, such as Canada's 1,000-mile-long Rocky Mountain Trench, are called rift valleys. Studies of the lithosphere indicate that volcanic activity, faulting, and distortion of rocks through folding and bending are most pronounced at the boundaries or margins between plates. Plates carrying continental landmasses differ from those lying under ocean floors. As a general rule, plates made up of continental crust are thicker and lighter than plates of oceanic crust. Earth scientists describe three basic types of boundaries between plates, each resulting in different kinds of surface features. Divergent margins occur where oceanic plates are spreading apart and new seafloor material is being formed, as is happening along the mid-Atlantic ridge. Most divergent margins between oceanic plates are underwater, but an example can be observed on land in Iceland, a volcanically created island bisected by the mid-Atlantic ridge. In addition to rifts in the island's rocks, the zone of divergence is marked by volcanoes of various sizes, along with hot springs, fumaroles, and geysers. Continental plates can also spread apart, as is happening along the East African Rift and in the Basin and Range region of the southwestern United States. In these regions, the Earth's crust is being stretched rather than compressed. Transform margins are found where two plates are sliding past each other, as can be seen along California's San Andreas Fault. Major strike-slip earthquakes occur along such boundaries, but forces for mountain uplift are often relatively minor. Mountain building is most strongly associated with convergent margins where crustal plates are colliding. Convergent margins can be subdivided into three basic categories: margins where oceanic plates converge with each other, those where oceanic plates collide with continental plates, and those where continental plates collide to form a single landmass of continental crusts. Island arcs formed as submarine volcanoes grow above the water surface are associated with the collision of two oceanic plates. Examples include parts of the Aleutian Islands and numerous islands in the Southwest Pacific. Other Pacific islands, including the Galapagos and Hawaiian island chains, have formed over hotspots beneath the plate and are not associated with plate margins. Where oceanic plates collide with continental plates, the lighter continental plate overrides the denser oceanic plate, and the crustal material is subducted or thrust downward into the Earth's mantle. As this happens, the edge of the continent is transformed into mountain ranges, such as the Andes, that combine overthrusting and faulting with explosive volcanic activity. Many of the world's active volcanoes are concentrated in zones of subduction, particularly along the Pacific Rim. Sometimes an entire oceanic plate is subducted under a continental plate, so that two continental plates are shoved against each other. This happened when the plate carrying the Indian subcontinent collided with the Eurasian plate about 50 million years ago, thus creating the intense pressures that are still building the Himalaya. The strong compressive forces generated when continental plates collide result in mountains that are primarily composed of highly distorted sedimentary rocks. Because colliding continental plates are too light to be deeply subducted into the mantle, the continents crumple against each other, pushing up enormous mountain chains along the collision zone. As this occurs, one continent is typically forced beneath the other, resulting in a massive deformation of the rock. For example, as the Indian plate collided with the Eurasian plate, it began to slide under Tibet. Rocks bent and broke under the impact. In a process called accretion, the Eurasian plate scraped relatively soft sedimentary rocks off the Indian plate and pushed them into complex tilts and folds. This combined with extensive faulting as the Indian plate continued pushing northward. Accretion and compression have produced an extremely thick continental crust under the Himalaya and the adjacent Tibetan Plateau. Because continental rocks are relatively light and buoyant, such thick concentrations float above the denser lower mantle. As a result, Himalayan valleys have elevations of 9,000 to 12,000 feet above sea level, and parts of the Tibetan Plateau, just north of the collision zone, have average elevations ranging from 12,000 to 15,000 feet. Several of the peaks rising vertically from such high bases are among the world's highest mountains. In summation, the Earth's great mountain chains have formed as a result of tectonic activity along the margins of lithospheric plates. Although mountains are built along all types of plate boundaries, most of the world's major mountain systems lie along convergent boundaries. Volcanoes are common in zones where oceanic crust is being subducted, as in the Andes Mountains of South America. In contrast, mountains such as the Himalaya, which are formed by a collision of continental plates, are primarily composed of sedimentary and metamorphic rocks that have been distorted by folding and faulting. These and other mountains continue to rise as the Earth's landscapes evolve.